develop high-performance sites and modern apps with JavaScript and HTML5. My name is Doris Chen. For those of you who may not know me, I'm a developer evangelist at Microsoft. So I think last time I presented here, that was about 6 or 7 years ago. At that time, I worked very close with Java community. I was a Java evangelist with Sun Microsystem for about 10 years. About 4 years ago, I joined Microsoft, and my focus area is still web, and I have been spending a lot of time working on HTML5 and JavaScript. And performance tuning is really my favorite subject because I still remember at the very beginning when I joined Sun, not Oracle, I was actually working on Java Swing performance tuning kind of team. So this is something really interesting. Today we're going to talk more about JavaScript performance tuning. And then I list my blog address there because I usually post my presentation, as well as this particular presentation actually is extract from a one-day training course. So I just recorded about a week ago, and it's totally free, and I will be sharing with you when it's available online. So if you want, you could copy down the URL for my blog. But to be honest with you, I usually don't remember the URL myself. So you could do a search. You type Doris Chen space MSDN, and usually the top 2 links, one of them is my blog address. You could also find me online at Twitter at Doris T. Chen. Notice there's a T in the middle. So if you, some people said I never respond back to them, it's because they type Doris Chen, missing a T there. Okay, make sure it's Doris T. Chen. And this is my email at Microsoft, a very typical one. And feel free to let me know how do you feel about this talk. Give me some feedback. Okay, so basically I'm a web person. Been working on the web for more than 10 years. Actually, before I get started with, I'd like to get a little idea about you. I was wondering how many of you actually are pretty good at JavaScript already? Okay, very good. How about a sort of like a beginner level kind of JavaScript? All right, okay, very good. All right, so this is the agenda, pretty simple. We're gonna actually start with some of the best practices for writing good JavaScript, right? Usually good code meaning it will be faster. It will be much better than the other way of writing it. And then we go into a casual game. Let's have some fun with that, and at the same time, let's try to make it a little faster. And we're going to use 5 principles. And these are the 5 principles you could apply to your application. So today, I'm showing you the running in a browser as a web application, but all the same principles, best practice, will be applied for any what we call cross-platform app development, right? You could use JavaScript, HTML5 to develop the apps running on, say, iOS, Android, Windows, right? Cross-platform. So it's the same principles. All right, so first thing first. Now, a lot of you are already very good at JavaScript, and I'd love to share with you some of the tips and tricks still working well. And some of them may be a bit of review for you. Still good to use in HTML. Where should you put your CSS? It's a test for you. Should you avoid the inline code? How well do you use JSON? How many libraries do you use? Do you create some duplicated libraries? Let's take a look. And then there's another 50 tips you could actually get it from another talk, which is on channel 9. I listed the link here. You could get a slide later on, or you could take a picture. Okay, so let's go over one by one really briefly. In HTML, this is still something pretty useful. You could have really just putting things there and getting, say, things like a username or something simple without really go through really sort of fancy DOM manipulation. It's still fast. So if you can, use it in HTML. The other thing you should really avoid is the inline JavaScript. or inline CSS in general. The reason is if you put inline code in the HTML, a lot of time for the debugging purpose or maybe just for the convenience, right? Just I try to fix something, right? But you're not realizing is you're creating two different containers. You're creating markup HTML, you have to have that. You're creating another JavaScript container. When you're working with inline JavaScript, you have to switch to another container. And when you finish working with all the inline code, go back to the HTML markup, you switch back to the HTML. So between two containers, it's going to take a resource, right? It's going to basically waste your time to do back and forth. So if you can avoid inline, try to put it into an external file. Do not just put it there for the convenience, right? That's another tip to share with you. How many of you still using XML for web service? Okay, in general, if you can use JSON, you should always use JSON. JSON is always faster than XML representation. I totally understand you have some code with SOA, web service, you have some XML representation. But in general, you have to take care of all the XML parser, right? You have to do all the work, and the JSON is so much faster. Why is that? Because JSON provides you the native speed kind of JSON processing method. So with JSON, you know, you could use parse, right? JSON parse to parse that string object, and then you could use stringify, right, to actually getting the string back from the object. So if you use JSON, JSON is always faster. You should always use all the parse and stringify method. These two are fully optimized, and they're good, right? So you should always use that. Another tip. Okay, remove duplicated code. Now, I showed some code here, and you notice that I actually put a jQuery twice. And everybody was like, you think I'm stupid or what? Of course I know this is a duplicate, okay? But what you may not know is, if you have a pretty long HTML, you may put a jQuery somewhere, and maybe you have another file, some HTML inside your project, and you may put another copy of jQuery there. Or maybe you use another library, and that library internally called jQuery. So you could go back to your code, check. I bet a lot of times you put a jQuery at least twice, all right? But you could remove them, because jQuery, all the code, the library is going to take time to load, right? Why you have to waste your resource to the time to load the library, the same piece of library, again and again? Okay, you're laughing because you think, oh, I never make such a stupid mistake. As a matter of fact, not everybody is as smart as you thought. 52% of top websites, they have duplicated code. Okay, so basically means only 48%, less than half of the people really check the code, make sure there's no duplicated code. So do not overlook that. It is something, you could check your code and maybe make your JavaScript code even faster. Okay, so this is a pretty common mistake. Another thing is, we know there's a lot of frameworks. From different conference, from this conference, you heard so many different frameworks you could use. But a lot of times, you probably will notice a lot of those frameworks, they may do similar things. But for you, just for the convenience, just say, oh, this library sounds like cool, right? Let me put it there. But they're doing very similar stuff. You're wasting your resource to getting a bunch of libraries, frameworks used there. As a matter of fact, maybe you only use one API. Or two APIs, right? Why don't you just stay with one single framework? Consolidate them. Do not put in all the frameworks just because you may want to use one or two, right? This is another tip for you. Because you could actually gain the performance, depends on obviously how many frameworks you're using. But based on our study, sometimes you could save the loading time up to 50%. The other thing is also pretty common. Maybe you just join that team, you want to impress your team member or your boss, you just say, look, I know all those cool JavaScript library. I'm going to use all the Facebook, Twitter, all those things, Google Analytics. But do you still need them? Sometimes you maybe just play with that, do some experiment. But then you finally forgot to remove them. You still leave them there, right? Make sure, clean up your code. Right? Do not try, just leave there because they're cool, because you may not use them at all. Okay, so few of those things is I personally also made that mistake, especially like a duplicated code. And some of them is actually by talking to developers, we're looking into some people's code, and that's why we share with you. Okay, so the other things I think, I go a little fast. Hope it's okay with you. Is it okay? The speed is okay with you? Okay. Because with modern browsers, with modern apps, right, performance tuning is a classical subject. It's been there since any language was born, right? Always try to make the code run faster. But what are the things we really care about these days, right, with apps running? So I listed 3 things here. The first one is called vsync. This is basically for the UI responsiveness. It's called a VI responsive. It's basically say you have a frames per second, right? Usually 60 frames per second is a perfect score because human eyes only take 60 hertz. So above that, you won't be able to see it. 60 frames per second, it's a perfect score. So this is the vsync. We're going to use this parameter to check our game later on. Second thing is GPU utilization. All the modern browsers, they're competing on the speed. One thing they're competing on is GPU, hardware acceleration. This is something browser doing a lot of work try to make it really fast. This applies to JavaScript as well as the CSS, right? So there's not too much we could do, especially for this particular game. The important thing we're looking into is UI responsiveness, the first one, and CPU utilization. Why CPU is so important? CPU is directly related to your battery life. Think about everything. I have a cell. My battery life is very important. When I try to get a device, a mobile device, I will check my battery. I tell you, battery life is very easy to get into a situation getting what we call too hot. It's basically called the heat mitigation. So for example, most of the phones, if you use more than 5 watts, that means you already hit that threshold. Okay, very easy to get it. You download a map, right? You get maybe 2 watts to engage with basically the core, right? You use 2 cores there. You maybe use another 2 watts just to actually getting the internet, the network to working. You may be using 1 watt just for the antenna, right? So this, you get a downloading a map, you're already getting 5 watts. And then once you reach that threshold, it doesn't matter you keep on charging or not. It's not going to give you much life, meaning you could not run another app at the same time, right? So you have to be careful about use the CPU as less as possible. And the CPU, there's a lot of things contribute to that. And then for this particular one, for this course, we're going to actually talk about JavaScript, how to write a JavaScript to reduce, how to work smarter with DOM manipulation, and all those things to help you reduce the CPU. So smarter CPU, better battery life, better user experience. All right, so let's actually move on to the game. Okay, so basically we have a single player game. It's a casual game, and it's a high five game, right? High five, you hit somebody, it's a high five game. And then if you want to take a source code, you could look at it here. I will post all the source code here. Okay, so let's actually try to run this. Oops. Okay. This is a hi-fi game. I touch any of the players, they're going to rotate to the neighborhood, and then causing their neighborhood to generate a rotation until it's done, right? And then obviously this is a little small scale, and definitely I could actually run it into a larger scale like this, right? This you see a lot of objects, a lot of matrix running. And then what I want to actually show you here is I want to use, this is IE 11, and of course you could use any of the browser, but IE seemed like a natural choice for me. And we could actually use, seems like my mouse is not working too well today. Okay, so let's take a little data. And let me actually turn off the music. Because after you do the debugging, try so many things, you just get a little sick of the sound, right? But I want you to hear that's a sound you could play. Okay, so we're using F12 tools. Hit F12, it's called IE Developer Tools, and you could use any other browser to do that. But there's one unique feature I want to share with you. It's called UI responsiveness. It's starting with IE10. And what you could do is you could actually see the visual throughput through here. And then you could also see the CPU utilization on top of that. It's called the UI responsiveness. And then obviously, if you're looking at a diagram like this, because 60 is the perfect score, right? And then if you see a lot of, a little like a dip here and there, that means the performance is not that smooth. And then what you could do is you could look into the CPU utilization to see why it's so full, right? And there's several color coding, meaning they're spending different time on different things. For example, one thing I noticed, there's quite a bit of garbage collection going on. There is quite a bit of starring back and forth, not much loading, right? There's some rendering, and there's some JavaScript as well. So you could see from this diagram to see what's the little bit of like a duration, which method actually spend the most of the time, right? And I could even look into, say, for example, I want to look into a little small scale, like here, right? And let's just take a quick look. Let's see if I zoom this, then you could see, this is more garbage collection going on, and I could even zoom into more to see why it's, what method is causing all the garbage collection, what's really, going on here, then you could see more information, all right? So different color coding meaning different stage. Like in this case there's a lot of object creation through different stage. And see, there's a garbage collection listing here, right? And usually you want to pay attention if it says UI thread, because when garbage collection happens, it's actually pause the UI thread. You wouldn't be doing anything, processing or rendering. So this is something you need to be careful. Why is that? Okay, so let's take a little closer to the code itself. Why is that, right? So let me go back to the slide. Okay, now, so let me just summarize. I don't know why this one is always there. Okay, here we go, good. Okay, so what you see here is, it's a matrix of players. If you go back to the game we just had, right? Each player has 4 sets of direction, right? Going this, going that way, right? And going the other rotation. And then every time I touch one player, it's going to causing the neighbor to rotate. And then the neighbor is going to cause their neighbors to rotate. So it's going to generate a list of neighbors to rotate until that particular list is done. Every time you hit a high five, you're going to get in your score, right? That's the whole game is about. And then obviously, if you look at it, the whole thing, it's a pretty simple game, but it involves quite a bit of JavaScript programming. For example, I'm using a lot of arrays. Creating a lot of objects to represent each player and the properties. I'm working with numbers because rotating, you have to work with some of the number, do the math. I'm actually working with animations, right? So basically what that tells you, I do have a lot of memory allocations in this particular game, isn't it? Okay, so let's actually take a little close look to that. So this is another screen snapshot of the visual throughput, and you could see it's not very nice, right? And obviously, every time when you generate those kind of benchmark, it would be very different because production environment is very different. Machine is very environment. So this is something you have to watch out in your performance tuning because your result, your benchmark would be different from mine, right? So I will share you my result, but you should always test it in your production environment. Make sure it's working, right? Okay, so like we said, you could use F12 tool, use this UI responsiveness tool to check what's going on. Or you could use Windows, if you use Windows, you could use Windows Performance Toolkit to do that. All those tools are free, it's part of the Windows. And then one thing, if you look at that, a yellow piece there, there's a lot of garbage collection. So basically, the first thing I look into is, do I expect such a huge amount of garbage collection to happen, right? So let's actually go to the first principle, stay lean for your code. Now, how many of you actually have the background of Java? Okay, so you all know garbage collection, right? And you all understand what's going on with garbage collection. So I'm not going to spend too much time to talk about that. And with JavaScript, it's the same thing. Every time you create new or implicit memory allocations, it's going to take up some memory, right? Until that pool is getting full. And then memory, when it's full, then garbage collection say, I have to do something, right? Garbage collection, you cannot enforce it. You don't know when it's going to happen. Right? When it's full, it will happen. Because in Java code, you probably noticed you could sort of say garbage collection, but it never worked. It doesn't really listen to you. You wanted to do some garbage collection? No. So, but we don't know when it's going to happen. We don't know if it's a critical moment when we want to see the response is happening, right? So every time any garbage collection happens, it's going to pause the UI thread. It's going to have a few milliseconds pause. That's very common. So accumulative, if you have a lot of garbage collection happening, you can have a big pause, right? So this is something you really have to watch out. Watch out what kind of object you have been created. Watch out how many implicit objects have you put in your code. And I will explain more to you what I mean implicit memory allocation there in my next principle. So first of all, garbage collection seems like it's a good thing to look into. So this is something I will look into my code. Okay, so, whoops. Okay. Can you guys see the code okay? I think my mouse is not working very well. Okay, so first thing, what I do is, this is just one piece of JavaScript code I use. Oops. Seems like we have more games here. Let me go back. All right. Okay, so one thing I usually do is I just go to a code and then look for new object creation. And usually I see, okay, not bad. There's some new array created the border size, and then it seemed like a pretty okay, nothing suspicious. Okay, let me move on. Yeah, it seems like the mouse is not working very well. Okay. Okay. Let's move on and then see if we have more. Okay, create a players, that's fine. Create some board size, initiate that. They all look okay. All right. Now, so one thing I want to check is the rotation part. And let me share with you what is the current way we did the rotation. So first of all, one rotation we did here is we actually, let me show you the slow version first. Okay, this is slow version. This is the current version we have. So every time when I do whatever northeast, right, and then maybe southeast, I'll make a 90-degree rotation, right? So the first approach we did here is we say, because we have a northeast, southeast, so according to 4 different directions, we're going to create another prayer just to respond to the northeast and southeast. So this is what we do. We actually try to create a prayer facing northeast, east to south, and the southwest and west-north. And then we realize probably we don't have to worry about that much. We don't have to create an individual prayer just for different direction. We don't have to even introduce like a northeast, southeast, because every time you do northeast or southeast, your east is not changing. There's only either north or south is changing, right? So by that, we actually go back to make the code a little bit better. Instead of creating more new directions, we actually just putting things like recycle the node. And when it's north, and we just check east and west. When it's just east, we check north and south. So we recycle all the nodes instead of creating the new nodes. So that's the step we actually fix. So let's actually fix it in the code. I just make it a little easier so that I have a okay, let's do it one more time. Sorry, bear with me. Maybe I touched something. Let's not save it. Let me open it again. So the full idea here is reduce all the objects we just created. And then try to see if we could reduce the garbage collection. Okay, here we go. Okay, so I'm going to actually call this rotate fast. So we'll rotate all the objects. And then make this rotate fast as well. So hopefully it will run. Okay, so let's run again. Okay, seems like it's still running well. So I didn't break anything. Anytime you do performance tuning, one thing you have to remember is do one step at a time. Make sure you don't break the code. Okay, still running well. Happy. All right, so let's go to our next principle to see if we could make it further. So fix the garbage collection. So based on the result, I don't have the time to show you. We reduce the 1/3 of the garbage collection. All right, so basically, in a way, we increase Java performance for about 3 times. So it's 1/3 of the garbage collection reduction. Okay, so here, what we learn here is avoid creating unnecessary object, like creating northeast, all the unnecessary direction. Make sure everything is lean. And use object pool, recycle all the nodes as much as possible. And then make sure when you do closure, when you do event handling, you should actually release the resource. Make sure you don't have objects still linkable with all the closure and event handling, because this is a common mistake. When you actually have a large application like this, our matrix board is very big. It could generate millions of loops like that. It's very crucial. And then make sure you could do not create implicit object. So we're going to talk about how to use fast objects and the manipulation. Let's actually take a look at an example of internal object type. So I have a P1. I have 2 properties. One is north, one is south, just like that. And for any of the JavaScript engine, first, they create a base type like this, empty. And then they're going to actually put north, say north, assign a property as 1, right? And go to south, right? So as create as 0 like this, totally fine. And now I have another object called a P2. And also with the same property, north and the south. However, this time, what we see here is we have south assigned to 0, and the north, the property assigned to 1, like this. Could somebody tell me P1 and P2 have the same object type? Object type meaning for the JavaScript engine to see that object, it will think it's the same object type. It doesn't have to create another object again. Anybody? P1 and P2 are the same? They contain north and south 2 properties. Nobody? Not the same. Very good. They're not. Even though it has the same property. But because you change the order of your property, for the compiler, when they look at the P1 and P2, they treat it as totally different object type. So they're going to create different object type again and again. Hence, it's going to waste some resource on that. So make sure you want to keep everything in the same order, even though they have exactly the same property content. One tip to share with you. Second thing, it's a pretty common mistake. We try to initialize a player. Sometimes we put some condition there. We're checking the direction, right, like this, and then assign a property to north or east. I do this all the time. However, you may not know, after you put in any condition, checking the condition and the play with the object type, these 2 object type, if you have a P1 and P2, these are not the same object type. You use a condition, you create different object type every time you actually instantiate anything. The right way to do is, do not put a condition. Just assign all the properties there. For 4 directions, let me put all the direction there. 4 properties. This way, all the P1, P2 are the same object type. Hence, it will be faster. So create fast types and avoid type mismatches. Do not put a condition checking. I did this myself. Go back to your code and check that. Another tip to share with you is prototype. How many of you love to use prototype in your code? Some of you, yeah. Unfortunately, the JavaScript compiler is not that smart. Once you use some prototype to initialize it, it cannot chase it back to figure out what is the object type with original object type. So every time you use prototype, basically you probably could end up with creating a lot of different P1, P2, P3 different object type, because compiler doesn't know which type you're talking about. So they have to create again and again. And a right way to do is just initiate it without a prototype. Initialize it with whatever you want. This way would be much faster. Then you only work with 1 object type. Okay, object type is very important, directly related to the garbage collection, and this is part of the implicit object creation. All right, so another tip to share with you: do not use a prototype if you don't have to use them. Another one is actually, I don't know, but people love to use operation called delete, right? Delete is a very slow operation. By using that, you actually have to force the conversion from faster type to slower type for the compiler to do the delete operation. So if you can, try to avoid delete. Just by simply use something equal to 0 or equal to null, that's good enough. You don't have to use delete. How many of you actually using delete in your code? All right, okay, go back, check it. I'm sure your program will run quite a bit faster. Avoid using that. Okay, another piece to share with you is array. I don't know, what would be a sort of like player size, right? In this particular case, I have like 256 properties assigned for that little player. This is definitely not a good idea. If you have so many players, properties in that player object, you probably should think about using array. That would be faster. Do not just use something like a player, have like 200, over 200, 300 properties there. That is going to causing this performance degradation. What the right way to do is restrict as few as possible to assign a property for any of the object creation. This would be a much better way. It would be much faster. And I will talk about array just in the next session. All right? So in general, avoid to use slow property backs. This kind of object player is called slow property backs. So control your number of properties you want to work with. This is something I think is very fun because we all encourage you to look into ECMA 5 and 6 to be a better JavaScript developer. And which is very true because, for example, you look into the way they do the enumeration, right? The way they do get and set, it's totally very readable. It is totally fine. That piece of code is fine. There's nothing wrong with that. However, if this piece of code is happening in your mission critical part, oh, this has happened to be in a big loop, you're going to run it millions of times, right? Large quantity of times. You can actually slow down by defining all the get, set, by doing all the enumerable in JavaScript. What would be much clean way to do, a much faster way to do is simply forget about the enum at a time, right? Just assign the full properties there. Okay, so this is actually another tip I want to share with you, and this is something I'm going to actually change it in my code because I also follow the guideline. I try to do a little ECMA, follow all those things, making the code more readable, right? I mean, if you're from Java, you're so familiar with all those methods, right? But so you could still do it if it's just happened like a process once or twice, but then you have a large loop. Stay with simple ways to do that. Avoid restrict all the get and set property descriptors. Okay, so that gives me another opportunity to fix my code. Okay. So this time, I'm going to work with my prayers. So let me actually just fix the prayer. Let me change it to a faster prayer. Fix this as a faster prayer. I have two prayers. One is called Mir, one is called Judy. These two prayers are going to actually take place in most of the time. All right. So let's save it. And let's take a look what's in my prayer. So prayer, which is a little slower prayer, is using all the get and set enumerable thing, which I did it before. The faster prayer is basically just assign 4 properties onto it. All right, so this is the fix I do. All right, so again, I fixed a little bit. Let's actually go back to see if it's still working. How do you force reload? Control or Shift to reload. Okay, okay, still working. Happy, I'm happy, it's still working. Didn't break anything yet. And I actually leave it to do a benchmark so that with a benchmark you could have the set of known sequence so that you could actually take in a benchmark and then you know the score, how high could it be. So have a little control. So this is what I did. Okay, so let's actually go back to see if there's any more room I could optimize my code. Move on. After this simple fix with an enumerable type get and set, I actually, again, increase my JavaScript performance by the 30%. So it's pretty good, 1/3 of the performance. Okay, what we learned for this particular principle is for the fast object creation and the manipulations, make sure you create and use fast types. Make sure you pay attention to the order of the properties in your object. Make sure your object is consistent. Right? Do not use a conditional to actually create your object. And make sure you don't want to do the create an unnecessary object type. So this is the second principle. The third principle is math. We all love math, isn't it? Let's actually take a look. Now, number in JavaScript is very, very flexible. It's very easy to use. We have to say it's a little bit easier than with Java, isn't it? However, because of the flexibility, there is a little bit of work, or a little bit of sort of like attention you need to pay for that. For example, how many of you know integer and the floating points, they have different bits? Integer is 31 bits, and the floating point is 32 bits. Okay, that 1 bit is very crucial. I'll tell you why. If you use integer, mostly integer, it's only 31 bits. 31 bits could fit into a stack. How many, anybody never heard about a stack or heap? Okay. So stack is actually one of the sort of like a memory chunk. It is actually it's a fixed size, and it's for much faster access. So if your data is smaller than 32, if your object is 31 bits, they could just fit into stack. You're working with stack, which is a lot faster. When your data is become a floating point, a string, or something like that, it becomes a 32 bits kind of object you work with. In that case, stack has a fixed length. It couldn't fit. It has to move on to the heap. Heap has a variable length, so meaning more dynamic, it's bigger. However, it has slower access. So basically, if you can, try to make things smaller, like use integer, stay with stack, it's faster, avoid to get into the heap. All right, so this is one sort of like a little background information for you to work with numbers in JavaScript. Now, if you look into the 31 bits integer and all the rest of them, let's take a look. If you say north equal to 1, 1 is basically an integer. So it's actually pretty good at fitting to the stack. It's 31 bits. Second thing you said, east is east. East is a string, right? In this case, east has to move from stack into the heap because it's a string, right? So it has to work on the heap. Point 1 is a floating point. So again, it's more than 31. It has to move on into the heap. And then hex number, any non-integer number is basically more than 31. So it's at least 32. So move on to the heap. Okay. So only integer could stay on the stack. The rest of string, floating, hex, any of those numbers have to move on to the heap. So that's basically how it's allocated in the internal JavaScript engine. Now, then let's actually take a look. When you do the math, right? If you don't have to use a floating point, that's a basic principle. You don't have to use floating point, stay with integer. If the precision with integer is good enough, stay with integer. Because you know why? Because it's 31 bits, it's only working on the stack. It doesn't have to move on the heap. So this way would be much faster. In this way, I'm actually doing the integer, the bar zero math, I'm stay with that. But if you have to use the floating, of course, you have to move on to the heap. Then it will be a little bit slower, right? So try to avoid use floating if you don't need. The other thing is, this is actually quite interesting. Now, with the Java, or even move on to the JavaScript, if we calculate a distance between 2 points, P1 and P2, we have very simple method to do that and compute the distance, right? Do the math. And then if you look at this particular one, right, I actually, in this one, point 1 is all integer. And point 2 is all integer as well. Point 3 is floating point, and point 4 is different format of a hex number, right? So if you look at all your data type, from this, I could actually fully optimize into something better, which maybe involve writing more method signature. However, it would be faster. So I basically tell the compiler, say, this first one is a distance floating point computation. The second method is the distance integer, right? Because why is good? Because whenever you actually put in the integer there, and then in calling the right method, the compiler is smart enough. It would do a little what called hotspot and a smart kind of optimization. It would say, okay, I know this one is just a floating, and I have to use a heap. This one is just an integer, right? And I just keep on working with integer. So it would be a lot faster for compiler to understand what you want to do. Hence, you could take advantage of the compiler's optimization without go back and forth with heap and stack with floating and integer. So this way it would be a lot faster. Now, you probably would say, does the modern JavaScript engine is smart enough to figure out what's really going on? Absolutely. The next generation JavaScript engine, you probably don't have to separate a floating method and an integer method. However, do the JavaScript engine a big favor. Make sure when you're calling those point 1, point 2, make sure the data is staying with the same. Right? So if you put an integer, then all integer, then the compiler knows it's all integer. If it's all floating, it's all floating. However, what if you put x is 10, y is 1.5? Then the compiler thinks, okay, sorry, this is an integer, but also floating. Okay, have to downgrade it into a floating kind of processing. So if you do that, then engine could not take advantage of recognizing if it's a floating or integer. So it's up to you when you write your code to make sure you could work with integer or integer. If you work with float or float, right, to take some advantage. So this is one tip to share with you. Okay, so wrap up for the math. Using the 31 bits integer as much as possible to do your math. Avoid using floating points if you don't need them. And make sure you take advantage of type specialization. When we say integer manipulation, floating manipulation, compiler is doing a type specialization mathematics. Okay, so these are the things we want you to watch out when you're doing your math. Okay, next principle, use fast arrays. All right, how many of you use arrays in your JavaScript? A lot, right? So how many of you understand how the compiler actually allocate your array? Okay, let's take a look. So I have an array, initialize the array, empty like this. And then I said my first element is 1, which is integer. Very nice. Put it into the array allocation. Totally fine. Next, I say my second component is a floating point. Okay, then the compiler say, so it's no longer an integer array. I have to create a floating array here. So it's create another array called a floating array type. And then copy 1 into here, put the floating point 2.3 into the second element. Okay, then I say, okay, I have another piece, third one, which is a string. Okay, the compiler say, okay, so we have a string then. Then I could have to downgrade or de-optimize into another array called var array. Var array is probably the slowest to processing array, right? Because you cannot use integer array, floating array, because you have to use string. So it's a var array. Then it have to copy the 1 into the new var array, copy 2.3, and then adding the string into it. So if, what does that tell you? So if you have an array with all kind of data inside the array, it's probably not a very good idea because the compiler has to basically allocate so many arrays based on your data type and copy each element into it until it finds one. Usually the slowest is var array, which is here, to hold all the elements in your array. Okay, so based on that, let's take further what we should do with arrays. Okay, so first thing, how do you allocate your array? Do you always put a little number? Like here, I said, I want to allocate 100 pieces of elements into the array. Do you do that? Or you just say, let's just, I don't know how many array elements I have. Let's leave it empty. Okay, a lot of times, maybe you don't, but hey, let's just put a best sort of like a size you could have guessed. 100 is not bad, right? So when you do 100, then the compiler say, nice, I just allocate 100 elements for that array. Piece of cake, very easy. When you do empty string like this, then the compiler will say, how big is that? I have a little default size, I start with that, and I will add 1 at a time. Okay, so it will have to increment your space 1 at a time like this if you do an empty array allocation. This is going to actually, think about it. If you have millions of those arrays, manipulation, incremented millions of times, that's non-trivial, isn't it? Right? So if you can, give the best sort of array size you can, put it there, right? So go back to your code. Yes, you have a question?
Does it double the size of the array as it goes every time?
No. The question is, does it double the size if you have more elements you need to know? It's obviously based on the the JavaScript engine implementation detail, but most likely it will increment 1 at a time. So it's very slow, yes?
All the rules are they applicable only to Internet Explorer and Microsoft implementation of JavaScript engine, or are they applicable to other implementations?
Yes, so this particular array allocation is applied to most of the modern browsers. JavaScript engine mostly is designed in such a way. It's especially working with array. That's why we actually, all the principles I'm talking about here, not just apply to IE, apply to all the modern browsers. All right, so this is something, specifically array, a lot of people, just didn't realize how much work if you leave an empty array like this. So we actually work with a JavaScript engine team at IE and Microsoft very closely. So we actually, they give us all the benchmark, they give us all the implementation detail. So we're getting little insight sort of share with you. Yeah. So the other tip is obviously, it's kind of like give a little hint. right? So when your JavaScript compiler, when they look at it, okay, they know the array size. So this is pretty big. It's about 100,000, right? But then they also want to know what's the nature of your array, right? If I do a hint, then they will say, oh, at least I know this is a var array. This is not an integer array. This is not a floating array. This is a var array. Okay, then I know what to do with that. It's not bad, right? Even though var array is the slowest, it's okay. It's better to give them a little hint rather than do not give any hint, initialize anything, right? And then you have to actually basically just say, okay, what's the first element? If it's an integer, give an integer array. If it's a floating, then I have to migrate into a floating. And then if it's a var string, it's a var string. So this is not a good practice. It will be slower. Give a little hint at the beginning and determine the data type right at the beginning so the compiler would take it from there and run a lot faster. Okay, so this is another tip. Go back to your code and check if you do any initialization. Give some hint for the JavaScript compiler. Yes, so this is something I want to emphasize. There is a type array advantage you could actually take. Instead of just putting all the elements into that array, like we showed in the beginning, you could actually separate them into a string array and a floating array or integer array. That way, it will work more efficiently. So you keep same data type into the one array. And then do not try to mix all the different data into the same array, because this is going to actually let a compiler, like I said, migrate into a different type of array. And with this, it would be a lot faster. And it could serve the same purpose, right? So separating array, if it's a floating points, get into a floating array. If it's integer, working with integer array. If it's a string, then of course you work with a var array. That's the sort of like the default one. Okay, so another thing I want to share with, this is a little bit sort of relate to things we talked about that before. You want to actually make sure internally all your type is kind of consistent. Now, this is a good example, right? A has 4 elements, 1, 5, 8, 9, all of them are integers, right? B is basically has all kinds of like hex data or the floating data. So in that case, A is obviously an integer array, and B here is a floating array. And then even though you don't have to separate the method in that case, you could work with the same array. But because you're smart, you give compiler easy time to work with, compiler could figure out A is an integer array, B is a floating array. Then compiler will actually use optimization to work on that. So here in your code, even though you don't separate these two arrays into different methods, it's still okay, you could add in those things. Whereas if you do something like this, A is a mixture of all data types, so it's a var array. B is a mixture of different data types, so it's another array. But this case, compiler has had to check in with individual element and to finally determine what would be a good array type. So this will waste some time to work on that. And this would be much better approach. Sounds good? Okay. Okay, so array. How many of you use delete to delete an element from an array? Did you? Okay, if you didn't use that, that's cool. It's actually another slow operation. It's again forcing the data type of conversion, the object type of conversion, and make it slower. So it's go back to the previous practice. You could just use all those matrix, like I say, assign to 0, assign to null, assign to something else, instead of using all the delete, right? Another tip to share with you. Okay, this is interesting. Enumerate arrays. How do you usually enumerate your arrays? Do you do like putting something called a var, something into something? Or do you do for each loop like this? Or do you do finally figure out, let's just do a simple, kind of like a for loop, right? And then you call this $8 every time? Okay. So I would say probably the for loop is probably the fastest way of enumerating your elements in an array. However, this is not the best way to do. If you run this particular loop millions of times, you have to compute $8 millions of times. So the better way to do is here to cache your length into a cache data. That way, directly into the loop with running a million times, but you don't compute this $8 length so many times. So you should actually always cache that length into the loop and continue from there. All right, go back to your code. I bet some of you actually, leave the way like doing things like this. All right, fix it. Okay, with array, we should make sure pre-allocate array, give a number, give a size, keep array type consistent, right? Keep all the same data type into same array. Take advantage of type array advantage of the optimization and so on. Also, keep the array dense, right? You should enumerate arrays in a better way, right? So you could use for loop, but make sure you cache your length. So this is for the fourth principle we're gonna go over. Next, we're gonna actually go over the last principle, do less work. Watch out what your JavaScript is executing. Okay, so this is actually a very classical example, manipulating with DOM. I'm sure everybody working with DOM, but you may not realize DOM operation is actually could be quite expensive. It could take quite a bit of time, right? So for this particular one, let's take a look. So I have a document. I get a particular one node called body, a particular one called game, and then calling the DOM manipulation API called get element by ID, putting an ID, and then I call another one called class list, and then I try to remove a particular class, right? Same thing, I do all the DOM manipulation until I try to add a new class. If you look at these two simple lines, this is actually two of the lines extract from one of the rotation from our game, right? So, is it a good way of doing things like this? It's gonna run millions of times like this. Anything wrong with that? Good, perfect. So, what's going on here is every time you work with this DOM element, you call body, you call game, you actually going back and forth with DOM and then JavaScript back and forth all the time. Okay, this is how it runs in the container part. And then for rotation, say we could do millions times of rotation, you look at how many operations you have. 1, 2, 3, 4, 5. 5 DOM operations you have to do until you actually go into the remove or add method. This is a very bad example. This is a very bad coding practice. You're actually doing too much unnecessary DOM manipulation. You could also creating unnecessary intermediate objects in the middle. Okay, so what would be a better way of doing that is basically cache your DOM manipulation into the element, like here, right? And putting everything here into an element, pick that element, and then use it in your loop. This is the right way of doing things. All right? So a lot of times you probably were changing things like a color, right? You're changing things with a particular, say, CSS properties. A lot of times you just didn't pay attention to that particular element. You didn't realize how many unnecessary operations you have been working on, right? Okay, pay attention to that because this is going to cost you. I would say this is $1 million tip. Okay, I want to really you walk away with all the principles, but this is a particular tip I want to share with you because we have been doing a lot of benchmark on that. We see a lot of people made this mistake without even realize they were doing something like this. Right? Okay, so another tip to share with you is this is related to our game because we have a border size, right? We have a different border size. Now, you probably know every time you're getting, say, document get item by ID, what you get is a string, right? You're always getting a string, right? So you do something like this. And then in your code, you're getting better. You said, I didn't really call this multiple times, right? I'm calling this .board size. What is this board size? Border size is really a string. Every time you want to convert a string into an integer, right? 1 million, 10,000, 100,000, that's a number. But you do this loop, you actually have to compute it, converting the string to the integer again and again. Why you want to do that? You should do it right at the beginning. Just say pass int, Just put a very simple method called a parse int. So if you work within integer data, you work with any data type you already know, try to actually always parse it into the right format from the DOM manipulation. And then use that particular parsed data into your code. This is another general tip for you, all right? So, if you look at this particular example, say our border size is 25 x and y direction, right, 25, 25. And then based on our benchmark, you could save 25% of marshalling cost, 25% performance marshalling cost, reduce that. It's non-trivial. It's 1/4 of the performance. All right, so just by simply doing a parsing, it's going to actually make a huge difference. So I'm sure you have a lot of data to parse in your code. Go back, take a look to see if you actually causing this automatic parsing in your loop again and again. This is another important tip we want to share with you. Okay, so this is about animations, about a set interval. How many of you use a set interval, set a timeout before? Yeah, if you do animation or do something else, you use it a lot. Now, there's a couple of ways of doing things, right? So you put a 0 there. What does that mean, 0? Basically, okay, let me go back. Human eyes could only catch up with the frequency up to 60 hertz. 0 means constantly update your screen, constantly checking your screen. Because 0, this is basically a milliseconds interval. 0 means non-stop doing it. So you're doing all those updating, but your eyes is not going to catching up, right? You only could catch up 60 frames per second. So basically, this is 60 we want to use, right? You don't want to do over that because your eyes is not going to see it. It's meaningless, right? So you're wasting a lot of resource to put a 0, create some UI sort of like update without even like seeing it. So a better way to do is you could set interval, use 1,000 divided by 60 hertz. That's about 16.667 milliseconds, right? You could do this, set interval like that, or set a timeout like this. Perhaps what would be a better way of doing that is request animation frame. How many of you use request animation frame? This is a much, much better way of doing that. Use the request animation frame. You don't even have to worry about what's the time interval. So your question is, then who is worrying about the time interval during the animation? Anybody? If I use a request animation frame, I don't put any time interval there, who is doing the job for you? Who is setting up an interval for you? Your browser, all right? So your browser, or the modern browser, is smart enough. As long as they support a request animation frame, they will actually figure out what would be the best interval for the browser to do painting and the UI rendering. So it is roughly close to 16.667 milliseconds. They use that as a guideline. However, it's more optimized. Every time they could change slightly with that 16 milliseconds so that it gives you the most optimized result. So if you can, use request animation frame. This is a big tip for you. Any modern browser will support request animation frame. All right, so we talk about a lot of principles, right? Let's actually go back to code a little bit to see if we could fix a couple more. Performance tuning is really depends on what's your performance criteria. You know, you could always keep on doing, make sure it's running fast. Okay, so one thing I did here is I actually use a benchmark. Like I said, I want to know how big the score is. I want to actually keep the known state so I know how much rotation it's making with a preset state. However, unfortunately, with this copy bench matrix, I actually set up a lot of the styles, all those things. So that's why in the beginning you see a lot of style setting. So instead of doing that, I say I'm going to change a little bit. Instead of doing that, I'm going to actually remove the benchmark kind of setting, but actually leave it with the natural way, which is just use a random generator. Here, I'm just using a random generator with mass, and I'm not controlling the sequence anymore. Okay, so that's first fix. Second fix is, remember, we talk about a set intervals, right? So currently, it's actually doing a timeout with a set interval, and to keep on saying, I know, changing every time you can. But then what would be a better way of doing things is actually, use request animation frame. and then get rid of the set a timeout, because this is, you're creating a lot of unnecessary UI rendering without really see it. Okay, so let's actually save the code. Let's actually try it again to see the performance is better. First, let me actually close this. Okay, and let me shift the reload again. Okay, good, still working. Let's increase the size. Oops, stuck a little bit. Okay, let's actually take the performance from there. Okay. Okay, let's take a look. So what you see here is from the UI responsiveness, it's getting a lot better, right? Compared to before, you see a lot of dip. You still see some dip in the beginning due to the garbage collection, but then most likely you hit 60 frames per second. Isn't that cool? So we did actually tune not so fast app, not so UI responsiveness functional kind of app into something which is quite a lot better. So use this tool, you could actually see quite a things going on, and you could, if you look at the CPU utilization, it's getting a lot less, right? It's getting less time for the starting, same amount of rendering, quite a lot of less garbage collection, and JavaScript is, you couldn't even see it, it's a little brownish kind of like corner here. Okay, so, happy? All right, cool. Okay, so let's move back to the slide. Let's see. So afterwards, we did some work, and then look at it, the frames per second is getting quite a lot better. You could use that to determine, and then better UI throughputness, meaning most of the work, most of response is 60 frames per second, which is a perfect score. And the meaning it's less CPU utilization. If you look at the other diagram, what means less CPU utilization? Longer battery life, right? Longer battery life meaning better user experience to working with any of the mobile devices, right? So again, the code is posted there. You could take a look at before and after to find out the difference. Okay, so in review, if you still remember, we talked about 5 principles. Watch out your memory allocation, stay lean, avoid unnecessary garbage collection, avoid unnecessary object creation, right? Remember, we have this direction, southeast, northeast, and all those things. Use fast objects, and then watch out how you do the fast manipulation. So watch out the order of your properties in your object creation. Watch out your object type, right? Do not use delete. Working with mass, what's the tip we shared with you before? Should we use integer? Should we use floating point? Very good, use integer, right? As much as possible. Use fast arrays, right? Arrays, we talk about a different kind of array type, right? Try to put an array type consistent as much as possible, right? Take advantage. If it's integer, if integer is faster, next floating, var array is the slowest, take advantage of that. What's in the do less work? Your DOM manipulation, right? You're creating a lot of intermediate DOM manipulation. Try to make it, assign an element with that. And do less work, use request animation frame, right? Okay, so with that, I want to actually leave maybe 5 minutes for Q&A, but want to share with you some resource about performance tuning. Performance tuning is a really complex subject. I give you about an hour, try to sort of like go through it. But really, when you get a slide, you have the URL. Notice it doesn't have the absolute URL. You could actually go through all the Steve Souders 2 books, right? High performance websites. Another one is even faster website, best practice. And there's another book which is also good called High Performance Browser Networking. JavaScript patterns, you could have all those patterns, and obviously one of the sort of well-known one is Douglas Crawford's JavaScript, the good parts, right? So you probably maybe you already see that book. There's quite a few JavaScript performance tuning tips we share with you, and you could find a resource here. There's also a W3C standard web performance site. You could look into, working with the timing, work with what are things they're gonna look at, what the progress. There's a few blog posting will tell you more about the JavaScript performance as well as for the Windows. And the tools, if you're interested to use F12 on IE, there's more tutorial to tell you how to work with the tools, right? So another piece is I contribute to the community. I usually run a one-day course for HTML5 and CSS3. So now it's all the material is here. It's all free. You could actually, most likely it's on my blog. You could go there and getting all the training material you want. And the last but not least is IE has a lot of what do we call test drive. Basically, test drive meaning you could actually look through each one of the HTML5 new feature. And then, for example, you could look at like a different feature. For example, you could do the, I don't know, pick any one of that. Touch, right? Or the web fonts, or web workers, WebSocket, say app cache, IndexedDB, all those new features. You could actually look into one of the example, take a look at the code, right? By using F12 tools or any developer tools, you could see the code. So with that, I think I have about 4 minutes left. Do we have any questions? Yes, I will post a copy of the presentation already given to the conference, but I will post the presentation in my blog as well. Sure. Any other question? All right, very good. You've been very good, audience. Thank you very much. I'll be staying here for another couple of minutes in case you have that.